Hello everyone, I'm Snigdha Kakkar and this is my channel AccelerateAICareers. Today we are going to solve a very interesting LeetCode problem, LeetCode 77 combinations. So what does this problem say and why is it important? So it's a favorite question of faang companies, has been asked by Amazon, Google and Microsoft in their interviews in last 6 to 12 months. Now what does this question say? So you have been given two integer values n and k. You have to return all possible combinations of size k which can be made out of the range 1 to n. So you can choose any numbers between 1 to n, 1, 2, 3, 4, and you have to make combination of size k and return all the possible combinations. You may return them in any order and the combinations need not have permutations. So basically 1, 2 and 2, 1 are not two different combinations there. There's only one. So you cannot have duplicates there. Let's look at an example to understand it better. In example 1, you have been given n equal to 4 and k equal to 2. So here basically you have four choices, 1, 2, 3, 4. And you have to find all the possible combinations of size 2 since k is equal to 2 is given to you here. And how will you find it? So we will use backtracking approach by default. And how does that tracking approach is represented? It is represented by a decision tree. So say suppose I pick up 1 as a number which I'm going to use in every combination. So what are the other numbers I can include with 1? So with 1 I can include 2, or I can have 3, or I can have 4. So 3 combinations I found which are unique and which have 1 in them. There's no other combination possible. Now say suppose I want to pick up 2 as a number which is there in all the combinations. So I pick up several combinations 2, 1, 2, 3 and 2, 4. But if you notice 1, 2 and 2, 1 are the same combination. So repetition is happening. How to avoid such a repetition? So to ensure that, always pick up numbers which are after 2 and no number before 2. Because it has already occurred and we have already made combinations using that number. So we can skip this combination. Now when it comes to 3 and I choose to have 3 in all the possible combinations, then I'll have to pick up all the numbers occurring after 3 and nothing before 3. So 3, 4 is the only possible combination. And after 4 there is nothing, so there is no combination more possible with 4. All the combinations which could have been with 4 are already covered, like 1, 4, 2, 4, 3, 4. So your overall answer is this. All possible combinations of size 2 with these numbers are these. And you can see the output here. This is the same list given to you here as well. And they have also given an explanation that 1, 2 and 2, 1 are considered to be the same combination since they are unordered. So I hope it is clear. So what's the time complexity of this solution? So we have decision tree of depth k because we are picking up size 2 combinations every time and we are picking that from n numbers. So the n raised to power k would be your time complexity, but again you are cloning these combinations every time you pick them up. So you clone them k times. So this is your time complexity which the examiner is expecting from you, but it is not very tight bound if you see from the answers here from the decision tree. So a tight bound answer here would be k multiplied by n factorial divided by n minus k factorial. Essentially, the formula for getting the number of all possible combinations is this, and it's multiplied by k. So I hope you understand the time complexity as well as the solution approach we are going to take. So let's start coding it. So I'll first of all initialize my result variable with an empty list where I'll capture all the possible combinations. After that, I'll write a nested backtrack function and I'll pass two variables to it. One would be the start, where I start from, like which number I choose to start from currently for the current combination, and the ongoing combination value. In the backtracking function, I'll first check if my length of combination is equal to k. So if I have achieved the length k, I have to append this combination to my result. So result.append combination, but I might need to change this combination at a later stage. So instead of appending combination, I'll append its copy so that even if I change combination at a later stage, it doesn't impact what I have added to the result state. And I return. If the length is equal to k for combination, I append it to the results. What if the length is not equal to k? In that case, I loop around for I in range start. And how far will I go? I'll go till n plus 1, because in Python the n label is non-inclusive, so hence n plus 1, and then I append I to the combination. So after this, once I have appended to the n to the combination, I apply backtrack I plus 1, because I have to make the backtracking call. It's a recursive call, right? I've already worked with I, so I have to make the backtracking call to I plus 1 and pass the current combination through it. Now, once I have worked with I, maybe I chose to include some other number and not I. So I have to go back, right? So I have to clean something in the combination. And how do I clean? I pop it out. So I basically pop the I out to add the new number. And now there's only 2 tasks remaining. I have to call this backtrack function. And initially, I'll not pass 0, but I'll pass 1, because in the question it's been mentioned that the numbers, the combination range from 1 to n and not 0 to n. So the start could be 1 but not 0. So I pass 1 and I pass an empty list, because initially my current combination is an empty list. And after that, I need to return my result. So this is my entire code. Let's run it. Accepted. So let's submit. So as you can see, it's working great. Even though the time complexity, if you would have seen, didn't seem to be that great, but the solution is doing really well. So let me just summarize so that you can do it yourself. So I initially initialized result with an empty list. Then I wrote a nested backtracking function and passed 2 variables. One is start number and the second value is the combination, current combination. And then I first check if my length of combination has already become k. If it is already k-sized, then I need to append it to the result. I might change combination array later on, so I have appended a copy of combination and then I return. Now I loop around in starting in range from start and looping till n plus 1, because the n value of the range is always non-inclusive in Python. And then I append the I value to combination. And I backtrack with I plus 1 as start index and the current combination as an input for it. And finally, I do some cleansing activity and pop the I out of the combination. And finally, I call the backtracking function from outside. And I'm calling it with 1 because it has been given in the question that you have to pick numbers from 1 to n range and not 0 to n. And I pass an empty list as the current combination, because we are just beginning to solve it. And you return the result. So I hope you understand the question clearly. If you have any doubts, ask them in the comments. I'll be happy to address it. If you like my way of solving the problem, subscribe to my channel to get your notifications for your daily LeetCode challenge. If you have any question which you would like me to prioritize to solve this, mention it in the comments. I would solve it next. Thank you.